Rational functions. Rational functions can be considered as a generalization of the polynomial. Actually, as a rational number, rational numbers are defined in terms of the quotations of integers. Rational functions are defined in terms of the quotients of polynomial. So the following example can be considered as a rational function. Okay, f of x is 1 over x. So the polynomial is 1 here. Numerator is 1. This is 1. And denominator is x polynomial, linear polynomial. We can give some other examples. For example, x minus 3 over x squared minus 1. So here, this is a linear function, polynomial. This is a quadratic polynomial. So this is a rational function. We can use several examples. Also, constant function or polynomial function can be considered as a rational function because in their denominator are 1. So we can define the rational function as the following way. Definition. A rational function is any function that can be written in the following form. In the form f of x equals n of x over d of x. Here d of x is different than 0 for all x. Here n of x and d of x are polynomials. So the domain is the set of all real numbers except d of x is different than 0. Okay, so domain of the f equals all real number such that denominator different than 0 for x values. For example, maybe we can use the above example. F of x equals x minus 3 over x squared minus 1 when denominator is 0 for x equals 1 and minus 1. So the domain of the f is all real number except minus 1 and 1. Okay, so this set is the domain of this rational function. The graph of the rational function is a bit difficult. I can give you some examples as a graph of the rational function, and on this example I can say something. For example, the graph of the x minus 3 over x minus 2, like this one. And here, this part of the curve, this is the graph of the function f of x equals x minus 3 over x minus 2. Here, this function goes to infinity when x approaching 2 because of denominator, because 2 makes the 0 denominator, so 2 is not in the domain. So x equals 2 is the vertical asymptote. Okay, so actually you don't know what is the vertical asymptote, but in the future again we will turn back to this topic. But x equals 2 line, this line is a vertical asymptote. For the rational function, we will need to analyze. So what is the vertical asymptote, what is the horizontal asymptote are very important for us. In this section, briefly, I will describe this one, but in the future, after learning limit, we will give the more general definition for the vertical asymptote and the horizontal asymptotes, okay? So here, the line, y equals 1 is a horizontal asymptote for the this function, okay? So here, y equals 1 line, this is the y equals 1 line, is a horizontal asymptote. Why these are asymptote? Here, when x approaching 2 from left or right, actually when x approaching 2 from left side, function goes to infinity. Okay, function is very large, takes the very large number. When x approaching 2 from right side, function value goes to minus infinity. So function takes a very large number again in the magnitude, but negative value. And y equals 1 vertical asymptote, the vertical asymptote y equals 1 says when x going to minus infinity, function value approach to y equals 1 value, or when x going to plus infinity, y approach to function value approach to y value, okay? Here we can say that y approach to y equals 1 value when x goes to minus infinity from above, so always f of x value is bigger than 1, but when x goes to minus infinity, this approach to 1. By giving the some negative value, x, big negative value x in this function, you can observe this situation. So this is the horizontal asymptote. From the right hand side also you can observe the similar things. So the number of vertical asymptote of a rational function f of x in general, n of x over d of x, is at most equal to the degree of the d of x. Okay, so because this is the root of that one, so not have to be, but the root of d of x, if the roots, let's say, according to the degree of that polynomial, we can mention, let's say this is the degrees n. So maybe there are n root, maybe less than n root, but let's note by the x1, x2, blah 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 xn. So x equals x1, x equals x2, x equals xn are the line which are candidate being a vertical asymptote, but does not have to be vertical asymptote, but they are candidate. Okay, when these are not vertical asymptote, I will explain in the problem in class lecture problem solving times. Okay, so may vertical asymptote, let's write may vertical asymptote. A rational function has at most one horizontal asymptote. In general, graph of the function can have a two horizontal asymptote, but for the rational function there exists at most one horizontal asymptote. Moreover, the graph of rational function approach to horizontal asymptote both as x increase and decrease without bound. In other words, when x goes to minus infinity or x goes to plus infinity. After learning limit, we will discuss this phenomena. I will solve some question in class lecture, okay? But before to solve the question, I can give the procedure to you to find the vertical and horizontal asymptote of the rational function. Sorry. So, vertical and horizontal asymptote of rational function. Consider the rational function f of x equals nx over d of x. So for the vertical asymptote, Actually, I don't like this procedure, but basically we can give. Later we will update this idea, so you will learn how you can find the vertical asymptote and horizontal asymptote more mathematically. Okay, so suppose n of x and d of x have no real zero in common. Okay, so n of x and d of x no real zero in common. If c is a real number such that if dc is 0, such that dc is 0, then x equals c is a vertical asymptote. Okay. Second case, if n of x and d of x have one or more real zero in common. Okay, or if n of x and d of x have one or more zeros in common. So in that situation, you should cancel the common linear factor. Okay, cancel common linear factors. What that means? So if n of x and d of x have a common zero, for example, a is the common zero. Okay, so we know na equals 0 and da equals 0. So that means nx equals x minus a factor, sometimes some other function. Let's denote by n tilde. And d of x has this x minus a factor again. So the rest part let's denote by the d tilde. Okay, so from here we can say that f of x equals, which is nx over d of x. We cancel the x minus a factor. So we have n tilde x over d tilde x. So you should make your observation on this rational function. Okay, so apply the case 1 to the reduced function. Okay, so here you should apply case 1. So again, if a is the root of the denominator d of x, okay, here, so x equal a will be a vertical asymptote. If it is not a vertical asymptote. So after making all cancellations, possible cancellation, you can decide the vertical asymptote, the meaning of this one. For the horizontal asymptote, first case, case 1, if degree of n of x is less than degree of d of x, then y equals 0 is horizontal asymptote. Actually, is the horizontal asymptote because this is unique. So is the horizontal asymptote. Case 2, if degree n of x equals degree d of x, then y equals a over b. What is a? A is the leading coefficient of the n of x and b is the leading coefficient of the d of x. Okay, is the horizontal asymptote where a is the leading coefficient of n of x and b is the leading coefficient of d of x. And the third case is if degree n of x bigger than degree of d of x. So in this case, there is no horizontal asymptote. Again, in the future, by using limit concept, we will discuss this situation. So that means actually the degree of numerator is less than the degree of denominator. So when x connected to plus infinity or minus infinity, y approach to 0. So y equals 0 is the asymptote. If the degree are the same, a over b is the asymptote. Let's turn back this example. Not this one, sorry. Here. So degree is 1, so degree are the same. So leading coefficient 1, so 1 over 1, y equals 1, y equals a over b is the 1, is the horizontal asymptote in this example, okay? And 2 makes the 0 denominator, but 2 is not the factor of the numerator. So x equals 2 is the vertical asymptote. Quickly, you can decide. When sketching the graph, we will use this important knowledge